Okay, in question 8.1, we're given f of x is equal to x squared minus 3x, and we're asked to find f prime of x from first principles. So let me just refresh your memory that the derivative definition is f prime of x is equal to the limit as h tends to 0 of f of x plus h minus f of x over h. Okay, so what we're going to do, we're going to find f of x plus h. Then we're going to subtract f of x to get a simplified numerator expression. Then we're going to simplify the limit so that we can evaluate it. Okay, so that sounds like a mouthful, so let's get going. So this is f of x here. So to find f of x plus h, all we do is we add an h in the position of all our x terms. So f of x plus h is equal to x plus h squared minus 3x plus h. I'm going to work quite fast here. So yeah, if you get a bit lost with the expanding out, just pause and do it yourself more slowly. So that's going to give you x squared plus 2xh plus h squared and minus 3x minus 3h. Okay, so that's our numerator term. And as you can see, nothing here will simplify. Okay, so that's as far as we can take that. Okay, so then f of x plus h minus f of x is going to equal to this expression here. Copy and then paste. Okay. And then we're going to subtract our normal f of x, which is x squared minus 3x. Okay, and then recall that that's going to give us x squared plus 2xh plus h squared minus 3x minus 3h minus x squared plus 3x. Okay, so what we're going to see is that this x squared is going to cancel with this x squared, and this 3x here is going to cancel with this, and what we are left with is 2xh plus h squared minus 3h. Okay, so then f prime of x is equal to the limit as h tends to 0 of 2xh plus h squared minus 3h over h, which is equal to, remember it's important to carry the limit when you're doing this, so then we can take out a common h, so we'll get 2x plus h minus 3, and we'll have an h on the bottom, and h's will cancel. Okay, so yeah, we can cancel that because that h is not 0, it's approaching 0. Okay, so then we get that f prime of x is equal to the limit as h approaches 0 of 2x plus h minus 3. And then if we evaluate this limit as h approaches infinitesimally close to 0, h can more or less be substituted by 0. So we just plug in 0 is equal to h, and then we'll get that is 2x minus 3. Okay, so what I'd recommend in a question like this is go back to your original function and use your well-known rules for differentiation. We know that it's going to be 2x minus 3. That's just from our simple laws that we have there. So that corresponds with our final answer here. Of course, if you don't have this, or in a question and your final answer for the first principles doesn't come out as the derivative that you can see from your rules, you've made a mistake somewhere in your simplification. Okay, so this is just rule-based. It's not particularly challenging, and it's a good 5 marks. So I think practice doing these types of questions.